Of evaluating limits analytically, we're going to look at a couple different types of problems. The first problem is asking me how fast a wrench will fall, or how fast the wrench will be falling after 2 seconds. So the idea they've given me here is that I have a position function of negative 16t squared plus 500 that gives the height of the object that's fallen for t seconds, and the height is 500 feet. The velocity is at time equals a, and it's given by this limit. So what it's really asking me to do is plug 2 in for the velocity. So I'll go ahead and rewrite this as the limit as t approaches 2 of s of 2 minus s of t all over 2 minus t. Well, s of 2 means I'm plugging 2 in for this function right here. And when I do that, I will get the number 436 minus s of t. S of t is negative 16t squared plus 500 all over 2 minus t. When I simplify this, I get a positive 16t squared. I get a negative 64 over 2 minus t. And then what I'm going to do is factor out my 16, and I'm left with t squared minus 4 all over 2 minus t. On the top then, I can factor again, and I get 16 times t minus 2 times t plus 2. On the bottom, I almost have what I have. On the top, I just need to take out a negative. And now I can cancel the t minus 2's. Plug in my 2, and so I'd have 16 times 4 over negative 1, which would give me a negative 64 for my velocity. The second problem here is a true-false question. There's two ways to explain whether it's true or false, and in this case, the answer is actually false. One way you could do that is by showing the graph. The graph of this function looks like this. So as you approach 0 from the right and as you approach 0 from the left, they're going to two different values. So this actually does not exist, this limit. The other way you can do this is by showing analytically how it does not equal 1. So you could find the limit as x approaches 0 from the right. And from the right would be numbers like 1, 2, and 3. So those are positive before you take the absolute value. So you'd be talking about the positive value of x over x, which equals 1. And then you compare that to the limit as x approaches 0 from the left. Those numbers are negatives, negative 1, negative 2. So you'd be talking about the negative x over x, which means this limit equals negative 1. They're going to two different spots, so the limit does not exist. So you could have used either explanation. You could have said that it's false because of the graph or because it's analytically, or you could say both. This next one is an actual theorem. So if you ever read this, if f of x equals g of x for all real numbers other than x equals 0, and the limit as x approaches 0 of f of x is equal to L, then the limit as x approaches 0 of g of x is also L. This is definitely true. This is a theorem. It's theorem 1.7 in your book. However, the theorem name is functions that agree at all but one point. I just need you to know that that type of statement is true. The squeeze theorem says this. If you have a function that's less than or equal to f of x that's less than or equal to another function for all x in an open interval containing c, except possibly c itself, and if you know the limit as it approaches c of f of x is L, and the limit as x approaches c of g of x is L, well, we now can say that f of x is also equal to L because it's squeezed in between those. I want to just mention that the squeeze theorem was what was used to find today's limits that we memorized. So what we're going to do is we're going to use the squeeze theorem to find the limit as x approaches c. C happens to be in this problem 0. So what we're going to do is we're going to write the limit as x approaches 0 of this first function. And I'm going to write less than or equal to the limit as x approaches 0 of f of x. So all I'm doing is I'm putting the limit as x approaches 0 in front of each part of these, because that's what I'm doing with the squeeze theorem. Then I'm going to just use direct substitution. So on this one I get 4, and this one doesn't give me anything because it's just recopying, and then this one gives me 4 again, 4 plus 0, which is 4. So therefore, by squeeze theorem, the limit as x approaches 0 of f of x is also equal to 4. It may be easier to see this in a picture, and I'm going to show you that before I end this video of what this picture really looks like. This says I'm 4 up, 1, 2, 3, 4, and it's a parabola that goes down. And this one says it's 4 up, but it goes up this direction. And they do touch each other right here at 0, 4. So you can see why the squeeze theorem works, because what you're doing is you're squeezing in between here, okay? And so the limit of this other function that falls between here has to be 4 because they touch at 0, 4.